Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 1 Higher Tier from 2019. Question number 4 is on the topic of electricity. Figure 2 shows a circuit that a student built. So you have a circuit, this is a battery, that's more than one cell, a lamp, and two resistors, or what we call fixed resistors. Now, although it might actually look like overall it's a series circuit, but the two resistors are connected parallelly. So you could say the lamp is connected in series to the resistor, but the resistors are connected parallelly to each other. So the lamp has a resistance of 10 ohms. So if I write 10 ohms, each resistor has a resistance of 10 ohms as well. What is the total resistance of the circuit? Now, if it's a series circuit, so if you have two resistors like this, and if they're each 10 ohms and 10 ohms, the total resistance is 10 plus 10, which will give you 20 ohms. Now, when you connect the two resistors in series, it would actually be the combined resistance of these two resistors, R1 and R2, should be less than 10 ohms. So which means the answer is less than 20 ohms, because you've got 10 ohms from the lamp and the total resistance from the resistors is less than 10, so it should be less than 20. Explain your answer to question 4.1. So the resistance, we can bring it up a little bit. So the resistance of the lamp is added to the total resistance of the resistors in parallel. The resistors in parallel have a total resistance less than 10 ohms. And it's worthwhile mentioning. So let's say I have two resistors like this, 10 ohms and 1 ohm. What will be the total resistance? Well, the total resistance is actually going to be less than 1 ohm, because it will be less than any of the single resistance. So it's not an average, you can't find it as an average. Now, there's an equation that you can actually use. It's 1 over the total resistance is equal to 1 over R1 plus 1 over R2. Now, in the combined science, you're not meant to know this equation, but they do actually test your knowledge on your understanding. So it's better to actually remember that equation just in case. Next part. The student replaced one of the resistors with a thermistor. Draw the circuit symbol for a thermistor in the box. A thermistor is a type of resistor, so it would have a rectangular shape and a line going across and a small line going horizontally. That's a thermistor. The student increase the temperature of the thermistor. Explain how the current in the thermistor changed. Well, when you increase the temperature, the current increased. Because the resistance of the thermistor decreased. Figure 3 shows another circuit that the student built. So you got a battery again, a cell, a bulb or a filament lamp, a resistor. Now this time in series to the resistor is a switch. Explain how the potential difference across the resistor and the lamp will change when the switch is closed. Now, when the switch is open, the circuit is actually working, the bulb will be working because the current flows through this path, through the bulb and through the resistor. Now, when you close the switch, the current that passes through the bulb, instead of passing through the resistor, will actually pass through the switch. It's actually, this is what you call a short circuit. So that means there's no current will be flowing when the switch is closed. So that means the overall PD or potential difference across the resistor is going to be 0. So the PD across the resistor is 0. Because you're trying to explain, you need to give a reason as well. Since there is a short circuit across the resistor. What about the lamp? Now, the lamp initially would be sharing the potential difference. Let's say they both are identical resistance. The lamp is 10 ohms and the resistor is also 10 ohms. If the battery, let's say, is 6 volts, then the potential difference across the light bulb is going to be 3 volts and is going to be 3 volts across the resistor because they'll be sharing the voltage. So when you close it, once the PD of this across the resistor drops to 0, all the potential difference will go across to the bulb. So visually the bulb will actually get brighter. So the potential difference across the lamp increases since the current increases. So when you close this, when it's open, the total resistance in the circuit is 20 ohms. When you open it, the total resistance of the circuit drops to 10 ohms. So there's a larger current going through the light bulb. That brings us to the end of this question, and I will see you in the next question. Thanks for watching.